Hey guys, here are the notes for 7.9 inverse trig functions. So you'll be able to apply inverse trig functions to solve right triangles. All right, so it says here in section 1 using a trig table. And a trig table is kind of like a times table, a multiplication table, something that's throwback that was used back in the day when students didn't have calculators. All right, so say you were asked to find the angle that is closest to the measure of angle A, what would you do? So take a second to think about that. Come up with a response, pause the video, and I'll show you what I did. And so I looked at this and I decided to use angle A as my reference angle and then take this side opposite and then the adjacent side since I had, that's an A, since this is a hypotenuse. And so I have O and A, meaning an opposite side and an adjacent side. And I know in my trig ratios, the trig ratio that actually uses an opposite side and an adjacent side is tangent. So if I take the tangent of angle A, that's going to give me the opposite side, which is 20 over 41. Well, I would definitely have to do that math, and you can do that. You can do the long division. But what I did was I looked at 20 divided by 41. I know that 20 divided by 40 is basically simplifies to a half, so that would give me 0.5. But this is not a 40, so it's going to be somewhere. I look in the tangent section, so I would say that my answer is going to be between these two numbers, meaning the measure of this angle would be between 26 and 27. Okay, so that's the guess that I would make. But now that we do have calculators, I don't have to make that guess. I can actually use inverse trig functions. So I'm going to say that my answer is going to be a decimal between 26 and 27. All right? But how can I use this trig ratio to figure that out? Well, that's where inverse trig functions come in. All right, so I don't have to use this table anymore. I can use this calculator. How do you do that? How do you find the measure of an angle? You take your calculator and based on the trig function that you used, so we did tangent A is equal to 20 over 41. I'm actually going to use the inverse of that. What do I mean by that? So if you notice, your calculator has the trig ratios here, sine, cosine, and tangent. But then in blue, right above them, there's cosine -1, sine -1, tangent -1. Those are your inverse trig functions. In order to use them, first of all, you always have to be in degree mode, okay? So make sure that you hit mode on your calculator. And then as you can see, I'm already in degree mode because I was doing a few problems earlier. So I'm already in degree mode. Most of the time, you're going to be in radian mode. So you have to, from radian mode, you have to go, right, if I click that, right, it's in radian mode. I have to shift over to degree mode. I'm going to hit enter, and then I'm going to clear it, okay? And so now I'm in degree mode. So I'm going to hit second tangent, because that's going to take me to my inverse trig ratio, and all I have to do is enter this same ratio, and that's 20 divided by 41. Close that. And that's going to give me 26.003. So the measure of this angle A is 26.03. And I'm just going to leave it at 26. Okay, so I was right? You're going to be somewhere between 26 and 27. Okay? So again, if we didn't have a calculator, you would have to use a trig table, but we do not have to use a trig table, and you won't have to. So inverse trig function. So if you don't have a calculator, a graphing calculator at home, you are going to need to get on your phone or go to your computer, tablet, what have you, and using your calculator, using whatever you're using, evaluate each of the following. For sine, I'll do the first one with you, sine. We are going to go to the inverse sine, so that is second. And then sine, and then I'm going to type in that close my parentheses, and that would give me a 26-degree angle. So the inverse functions, what do you think the purpose of the inverse trigonometric function is? How would you summarize what we use it to find? What do we use the inverse trig function to find? Fill that out yourself, okay? What did we use, how did we use it here? What did we use it to find, okay? A quick one-sentence answer, doesn't have to be very long-winded. All right, and then we have some examples here. All right, so it says solve for the angle theta, round to the nearest tenth of a degree. So I know I'm going to be working with trig ratios, so I'm going to write out TOA. And for that first one, we are given theta, so that's our reference angle. Okay, and then this is opposite, but we're not given any information about this side, so we know we're not going to be using the opposite side. So we're not going to be using any trig ratios that involve an opposite side. Okay, so it's not going to be this one, not going to be this one. It's more than likely it is going to be cosine, because here's our adjacent and here's our hypotenuse. So we have the cosine of theta is equal to 12 over 15. Now here you can do one of two things, because essentially what are we trying to do? We're trying to find this angle. Now, the long way of doing this is to look at it as I'm trying to get theta by itself, okay? So I have to do the inverse of cosine. The inverse of cosine is literally cosine negative 1. If you multiply cosine negative 1 times cosine, the two cosines will cancel. You'll be left with theta. But you have to do that to this side as well. And when you do that, you'll end up taking cosine negative 1 times 12, times 12 over 15. Or you could just look at it as this. Cosine of theta is equal to 12 over 15. If you're trying to find the inverse function, if you're trying to find the measure of your angle, and if you're using the inverse function, just multiply your trig ratio by the inverse function. This step I just do to make it clear as to why we're multiplying by the inverse function, okay? So the cosine of, we're going to hit second cosine, and that's 12 divided by 15, and we get a 36.8 degree angle. And they say round to the nearest tenth, it's 36.86, so it's going to be 36.9. All right, so theta is equal to 36.9 degrees. Try this second one yourself. And next page, solving triangles. Okay, so now here you're trying to solve for the entire triangle. You're trying to find your angles, your side lengths, all of that stuff, okay? So let's do, we'll find MN and the measure of angle M together, and then you'll be on your own for the rest, and including the second one, which you do need to think through. Do not say, oh my gosh, I just can't do it. You have to use, I'm pretty sure you'll be using the distance formula for the second one, okay? So it says find the length of the side. So I'm going to write out SOHCAHTOA. I always do that because it helps me remember the trig ratios and it helps me to figure out which ones I'm going to be using here. Okay, so we need to find the length of MN. Well, that's 28, so okay, we'll do MP. How about that? MP. So how do I find side MP? Well, I'm trying to find side MP, so I'm going to put an X here because that's the one I'm trying to locate. I have this 36-degree angle. Opposite that is my missing side, and then adjacent to that is this side right here. So I have an opposite side. I have an adjacent side. So opposite and adjacent, I'm going to be using tangent. The tangent of 36 is equal to X over 28. Set up a proportion. X is equal to tangent of 36 times 28. So then I just multiply those up. Tangent, regular function, not the trig function, tangent, let me just move this up. Tangent of 36 times 28. And that's going to give me 20, and they want to the nearest 20.3. So x is equal to 20.3. That means that MP is 20.3 units in length. Now let's go ahead and find angle M. So angle M is 90 degrees. That was an easy one. Let's try to find angle N. Angle N is 36 degrees. So go ahead and try to find angle P on your own and try to find all this other information. Do the second one as well, okay? Have a good night.